Girls just wanna have fun. Girls just. Oh my goodness, I did not know that was recording. I could have set that there. Pretend you did not see that, ladies and gentlemen. But today, in this mini episode here, we're going to discuss carbohydrates. So, carbs, aka carbohydrates, very, very important stuff here. They have multiple functions. We're not going to discuss everything about carbohydrates, but we're going to make analogies and discuss as much as we really can here in a short form. So, functions of carbohydrates, they're first off an immediate source of energy. So, it's a quick source of energy. Think of this as having a wad of cash. We're going to keep the same kind of analogy all the way through carbohydrates, but think of having a wad of cash in your hand ready to spend. So, this is immediate energy. Boom, you're going to the strip club. Boom, you're going to buy a pack of gum. Boom, you're going to buy a bucket of KFC chicken. Boom, there we go. We got that wad of cash in our hand, ready to spend immediately. Also, carbohydrates function as stored energy. So this is somewhat like having gold in a vault at home. So it can't be spent immediately, but you can break down that gold into a wad of cash, which is ready to spend immediately there. So immediate energy, having that wad of cash. Carbohydrates also function as stored energy. So this is the stored in the vault, ready to be used at a later time. So there's actual terms for these. So glycogen, or let's say glucose, is that immediate energy, that just quick form of energy that's in our blood sugar. That's blood sugar is glucose. That's what keeps us going, keeps us wired. But glycogen is the storage form of glucose. So think of glucose as the wad of cash, glycogen as that stored energy, as that gold in the vault. So there's a couple different ways this happens. So glycogen can break down into glucose, which can be used as energy, so breaking in that gold into the wad of cash, or vice versa. You can combine a bunch of cash, a bunch of glucose for a storage form of gold, or in this case, glycogen. So glycogenesis is many glucose coming together to form the glycogen, and glycogenolysis is the glycogen breaking down into many glucose there to ready to spend there. So whenever you're storing energy, all the glucose into glycogen. Whenever you're breaking down that energy to use it, break down that glycogen into many glucose, and it's ready to be used as energy there. So glycogenesis, an analogy would be the combining a bunch of dollar bills to get gold. Glycogenolysis would be selling all the gold to receive a bunch of dollar bills in your hand ready to spend. So glycogenesis is building, and glycogenolysis is breaking down there. So glycogenesis, glycogenolysis, glycogen, stored energy, glucose, immediate energy there. So they're kind of reversible back and forth. If you know one, you'll know the other, and so on and so forth. But so functions of carbohydrates, we got immediate energy, we got stored energy, also function as as cellular identification markers. So what the hell does this mean? So every cell does have an ID marker. So this ID marker is what really differentiates cells from so it's, think of it as the self versus not self. So we have all these cells in our body. This is the CAM cell. Let's say that we got a bunch of CAM cells, and then we have a foreign cell, let's say, in our body, and all these ID markers are CAM cells, CAM cells, CAM cells, and then this one's a foreign cell. So that foreign cell, our body's defense mechanisms knows, okay, this cell is not supposed to be in our body. Let's attack it and get it out. So it differentiates CAM from not CAM, or Bill from not Bill, or Susie from not Susie. So all of these cells in this body have identification markers to say, hey, this is CAM, this is not CAM, and obviously the defense mechanisms want to remove every cell that is not CAM. So cellular identification markers, it determines self versus not self. So every cell has these ID markers, and they either pretty much say, yes, this is supposed to be in the body, or no, this is not supposed to be in the body. So it's kind of the message to say, hey, I'm supposed to be here, or the sign that says, yeah, I'm not supposed to be here, I'm an invader. So it's pretty nice, or the invaders pretty much come out and say, hey, I'm not supposed to be here, please get rid of me. It makes our defense mechanism's job much, much easier that way. But also, cellular identification marker aids in proper tissue formation. So Remember, recall, tissues are two or more cells with similar function structures working together. In this example, ID markers allow all of the brain cells to combine to form brain tissue, or all of the liver cells to combine to form liver tissue. So it kind of knows, if you're a brain cell, you know, okay, you want to go to the brain. You aren't going to have brain cells in the liver cells in the brain, or anything like that. Just, it's analogous to being a distinction of a mammal that has a backbone, or if you don't have a backbone, you aren't a mammal. So if there's a backbone, it's a mammal. If it is a brain cell, it's going to go to the brain. If it isn't a brain cell, or if it doesn't have a backbone, a certain animal, it's not a mammal. So it's kind of the idea of this is what it is, or this is what it isn't, and that aids in proper tissue formation and just determining self versus not self there. So as for the kind of backbone with mammal example would be self versus not self. If it has a backbone, it is self, or it is the cam cell. If it doesn't have a backbone, it's not self, or not the cam cell. So if it has a backbone, it is a mammal. If it doesn't have a backbone, it isn't a mammal. So that's for the self versus not self aspect. And then as for the proper tissue formation, just think of how mammals form packs. So you won't see, for instance, so this is the liver cell in the brains, in the brain type of example. You won't see a wolf in a pack of lions, and you also won't see a zebra in a herd of buffalo. You'll only see buffalo in a herd of buffalo, and you'll only see lions in a pack of lions. So you only see brain cells in the brain, you only see liver cells in the liver, you only see heart cells in the heart, and lung cells in the lung, and that could go on for everything in our body there. So cellular identification markers, very, very important. Function of carbohydrates determines self versus not self, and also aids in proper tissue formation. So that combining of cells to form certain tissues, which ultimately form organs. And carbohydrates also function as a carbon source. Here's a carbon source. If you don't have enough carbon in your body to form other organic molecules, so protein, lipid, nucleic acid, if you need one of those to function properly, the carbohydrate will break down, and the carbon will break away from the carbohydrate and allow these other organic macromolecules to be used. So it's kind of like a wild card that could, break this carbon down, you could use it here, or if you want to think of it like think of carbohydrates as a package of batteries with this specific function of carbon source. So the carbon or batteries can be removed to help many things function, or in the anatomical case form. So the batteries will help many things function or form, such as you could use those batteries in a toy, in a remote control, in any other controller, essentially. It's a controller for a Xbox or anything like that. So that same carbon or battery can be used to form a toy, or function a toy, or a protein could be used to form a lipid or the remote control, or it could be used, that carbon from the carbohydrate could be used to form a nucleic acid, or help an Xbox controller function there. So there's multifaceted carbon from the carbohydrates. That's another function of carbohydrates, is to remove that carbon from the carbohydrate to form many other organic macromolecules there. So we got functions of carbohydrates: immediate energy, stored energy, that's the glycogen. Function as a cellular identification marker, which A, determines self versus not self, and B, aids in proper tissue formation. So remember, every single cell in the body has cellular identification markers to say, hey, this is who I am, or this is who I am, in a good way or a bad way. So if it says, hey, this is who I am, I'm Cam, your defense mechanism, for instance, will say, okay, this guy's good, this guy's supposed to be here. But if you got the poster of the invader on your head, defense mechanism is going to be, all right, we need to escort you out of here, sir or man. And carbohydrates also function as a carbon source. So if you don't have enough carbon to form other organic macromolecules, boom, strip the carbon away from carbohydrates. There you go, you can make whatever you want there. So it's a nice, it's good. Think of it like the battery. The batteries can be used for a toy, remote controller, Xbox controller, I'm not really even sure what else uses batteries, but think of it like that. Carbon from carbohydrates can make a protein, can form a lipid, form nucleic acid, all that, all the beautiful organic molecules out there. So in the next episodes here, we're going to discuss the different classes and continue our discussion on carbohydrates. Be right back after a short 30-second break.